I want to be completely upfront before we go any further. This is not a breaking news video. Yellowstone is not erupting right now. It is not showing signs of erupting anytime soon, and I checked the actual current monitoring data before I sat down to write this. As of the most recent official update, Yellowstone's alert level sits at normal, the lowest level on the scale, background earthquake activity, and no meaningful ground deformation. What I want to do instead, because I get asked about this constantly and because I think the real science here is genuinely fascinating, is walk y'all through a hypothetical, a thought experiment grounded in actual volcanology. If Yellowstone ever did produce a major eruption, what would that actually look like, step by step? And how does that compare to the wildly exaggerated version of this scenario that tends to go viral every few months? So let's dig into it, and I'll keep flagging along the way exactly where we're in hypothetical territory versus where we're talking about real documented science. Let's start with what Yellowstone actually is, because I think a lot of the fear around this topic comes from people picturing something that isn't quite accurate. Yellowstone sits on top of what's called a hotspot, a plume of unusually hot material rising from deep within the Earth's mantle. And that hotspot has been producing volcanic activity in this general region of North America for millions of years, with the North American tectonic plate slowly drifting over it, which is actually why you can trace a trail of older volcanic calderas stretching from Yellowstone back through the Snake River Plain in Idaho, each one marking roughly where the hotspot was sitting at the time. Yellowstone itself is what's called a caldera volcano, meaning that unlike a classic cone-shaped volcano like Mount Fuji, Yellowstone doesn't really have a single obvious peak. It has a massive collapsed depression, the caldera itself, formed by previous eruptions so large that the ground above the emptied magma chamber essentially caved in. That caldera measures roughly 30 by 45 miles, and a huge amount of what people go to Yellowstone National Park to see, the geysers, the hot springs, the bubbling mud pots, is a direct surface expression of that same underlying heat source, just released gradually and non-explosively through those hydrothermal features, rather than through a violent eruption. Now, here's an important piece of real documented history before we get into the hypothetical. Yellowstone has produced 3 genuinely massive caldera-forming eruptions over roughly the past 2.1 million years, the most recent of which happened around 640,000 years ago. Those are the eruptions that get referred to as super eruptions, and they were genuinely continent-altering events, ejecting enormous volumes of ash and rock and reshaping the landscape for a huge surrounding region. But, and this is the part that tends to get lost in the scarier headlines, Yellowstone has also had plenty of other, much smaller eruptions in between those 3 big ones, including lava flows that didn't produce anything like a global catastrophe. So Yellowstone erupts doesn't automatically mean worst-case super eruption, even in a hypothetical sense. With that real context established, let's actually build out the hypothetical scenario, because I think walking through it step by step, the way volcanologists actually think about it, is a lot more useful than just throwing around the word supervolcano and letting people's imaginations run wild. So, hypothetically, let's imagine we're watching the earliest stages of a real Yellowstone unrest episode begin to unfold, something meaningfully different from the background seismicity and minor ground wobble that's actually normal and common there. In this imagined scenario, the first thing volcanologists would likely notice, months to years before anything reached the surface, is a significant, sustained increase in seismic activity beneath the caldera. Not just the occasional small earthquake swarm that Yellowstone already experiences fairly routinely as part of its normal hydrothermal and tectonic behavior, but a persistent, escalating pattern, potentially including earthquakes large enough to be felt by people in the park and surrounding communities. Alongside that, the extensive network of GPS stations and satellite radar that already monitors the ground surface across the region would likely start picking up meaningful uplift, the ground literally rising, potentially by multiple inches to feet over a period of months, as magma or magmatic gases push upward and press against the crust from below. In our hypothetical, we'd also expect changes in the chemistry and temperature of Yellowstone's famous hydrothermal features. Geysers behaving differently than their historical patterns, hot springs shifting in temperature or composition, potentially new areas of ground becoming noticeably hotter. I want to pause here and make something really clear, because it's genuinely important context for this whole hypothetical. This kind of unrest, elevated earthquakes, some ground deformation has actually happened at Yellowstone multiple times in recorded history, including relatively recently, without ever leading to an eruption. The ground under Yellowstone rises and falls somewhat routinely as part of the normal, ongoing life of the volcanic system, and scientists have gotten quite good at distinguishing background wobble from something that would represent a genuine escalation toward eruption. So in our hypothetical scenario, we're deliberately imagining something well beyond what Yellowstone has actually exhibited in the modern monitoring era, a sustained, escalating multi-signal pattern that would represent a real departure from anything in the observed record, precisely because that's the kind of signature volcanologists say would need to appear before genuine concern about an imminent eruption would be warranted. Let's continue the hypothetical forward. If that kind of escalating unrest did occur, the next phase volcanologists would likely watch for is the transition from deep unrest to shallow, more immediately dangerous activity, specifically an increase in what are called phreatic or hydrothermal explosions, essentially steam-driven blasts that happen when superheated groundwater flashes explosively into steam, similar in mechanism, though potentially far larger in scale, to the small hydrothermal explosion that actually did occur in Biscuit Basin within Yellowstone earlier this year, a real, documented minor event that threw rocks a short distance into the air and was picked up by seismic monitoring, but that had nothing to do with magma reaching the surface and was over quickly. In our hypothetical escalation, we'd be imagining a scenario where these kinds of explosive hydrothermal events became more frequent, more energetic, and potentially began occurring in new locations across the caldera, signaling that heat and pressure were building toward the surface in a genuinely unusual way. Now, in this hypothetical, and only in this hypothetical, let's imagine that unrest continued to escalate all the way to an actual eruption. Volcanologists generally believe that if Yellowstone ever did erupt again, the most probable type of eruption, by a significant margin, would not be a repeat of one of the three ancient super-eruptions, but something considerably smaller, potentially a lava flow, similar to eruptions that have actually happened at Yellowstone in the roughly 70,000 years since the last super-eruption. Events that reshape the immediate local landscape without producing anything resembling a global catastrophe. In this more modest hypothetical scenario, we'd be looking at lava effusing from a vent or fissure somewhere within the caldera, an event that would be genuinely dangerous and disruptive to anyone in the immediate area, would likely require evacuation of Yellowstone National Park and surrounding communities, and would produce a real regional response, but that would remain a largely local and regional event rather than a continental or global one. Let's also walk through the far less likely, but obviously more dramatic, end of the hypothetical spectrum, because I know that's the scenario most people are actually picturing when they think about this topic, and I don't want to dodge it. I just want to frame it honestly as the low probability tail end of the range of possibilities rather than the expected outcome. If, hypothetically, an eruption did occur at the larger, more explosive end of the spectrum, involving a substantial eruption of the same rhyolitic magma that fueled the ancient super-eruptions, we would expect a genuinely catastrophic sequence of events in the immediate region. Pyroclastic flows, fast-moving currents of superheated gas, ash, and rock would sweep outward from the vent area at speeds that make outrunning them essentially impossible, devastating everything within a substantial radius, likely encompassing much of Yellowstone National Park and parts of the surrounding region in Wyoming, Montana, and Idaho. Beyond that immediate zone, a large eruption would loft enormous volumes of volcanic ash into the atmosphere, and depending on wind patterns at the time, that ash could blanket huge portions of the surrounding states, potentially reaching many hundreds of miles from the source in a thick, disruptive layer, and reaching much of the continental U.S. in a lighter, but still significant layer capable of grounding aircraft, damaging machinery and crops, and straining water systems and infrastructure across an enormous area. The climate impact is the piece of this hypothetical that tends to get the most attention, and it deserves an honest, careful explanation rather than exaggeration in either direction. Large volcanic eruptions inject sulfur dioxide high into the atmosphere, where it converts into tiny reflective particles that can reduce the amount of sunlight reaching the Earth's surface for a period of time, producing measurable global cooling, something we've actually observed after real historical eruptions elsewhere in the world, even ones far smaller than a hypothetical Yellowstone super-eruption. In the most extreme end of our hypothetical scenario, scientists estimate a Yellowstone-scale super-eruption could produce a period of significant global cooling lasting potentially several years, with real serious implications for global agriculture and food supply. I want to be careful here not to overstate this into some kind of instant apocalypse, because that's exactly the exaggerated version of this topic that spreads the most online. But a multi-year period of meaningfully disrupted growing seasons across major agricultural regions is a genuinely serious civilization-level challenge in its own right, without needing to be inflated further than the actual science supports. I want to bring this hypothetical back down to earth now, because I think the responsible way to end a thought experiment like this is with the actual probabilities, not just the dramatic imagery. The United States Geological Survey, the agency that actually monitors Yellowstone around the clock with one of the most sophisticated volcanic monitoring networks on the planet, has stated plainly that while another eruption at Yellowstone is technically possible, scientists are not convinced that one will ever happen again at all, let alone on the scale of the ancient super-eruptions. The statistical odds, based on the roughly 2 million year eruptive history of the system, work out to an annual probability of a major eruption that is genuinely comparable to the odds of a large asteroid impact. An event so unlikely in any given year that it doesn't meaningfully factor into how anyone should plan their life, and dramatically less likely than plenty of other natural hazards that get far less viral attention, including hazards like regular earthquakes, hurricanes, or tornadoes that we cover on this channel regularly because they're actually common enough to require real preparation. I also want to say something about why this topic goes viral so often despite that reality, because I think it's worth understanding. Yellowstone genuinely is monitored extremely closely, and that monitoring occasionally does pick up real, if minor, changes, a small earthquake swarm, a period of slight uplift, an actual small hydrothermal explosion like the one at Biscuit Basin. And because those updates are publicly available, it's very easy for that real but minor data to get pulled out of context, stripped of the actual scientific interpretation, and repackaged into an alarming headline that implies something imminent when the underlying scientists monitoring the system are saying the opposite. If you ever see a headline or a video claiming Yellowstone is about to blow or gearing up to explode, the single best thing you can do is go check the actual current alert level and monthly update directly from the Yellowstone Volcano Observatory. Because that source is public, it's updated regularly, and it will tell you plainly and without any dramatic framing exactly what the real data shows, which, as of today, is background seismicity and no significant deformation. In other words, nothing unusual at all. I want to spend a minute on the actual monitoring network itself, because I think it's genuinely reassuring once you understand how thorough it is. Yellowstone sits under one of the densest volcanic monitoring networks anywhere on the planet, run jointly by the US Geological Survey, the University of Utah, and Yellowstone National Park under the umbrella of the Yellowstone Volcano Observatory. That network includes dozens of continuously operating seismometers scattered across the calderas and surrounding region, capable of detecting even small, deep earthquakes in real time, a network of permanent GPS stations that measure ground movement down to the millimeter, satellite radar data that can detect uplift or subsidence across the entire caldera, even in remote, hard-to-access terrain, and regular sampling of gas emissions and water chemistry from the hydrothermal features themselves, since changes in gas composition can be an early signal of magma moving closer to the surface. This isn't a system that gets checked occasionally, it's continuous, 24 hours a day, every day of the year, which is exactly why volcanologists are confident they would see a genuine escalation building over months to years, not get caught off guard by a sudden, unannounced eruption. In our hypothetical scenario, that dense monitoring network is precisely the reason we imagined a slow, multi-stage progression of warning signs rather than a surprise event, because that's what the actual science and the actual instrumentation available at Yellowstone would realistically show us. I also want to draw a clear line back to the one part of this topic that is actually a real, everyday safety concern at Yellowstone, separate entirely from our eruption hypothetical, because I don't want the dramatic scenario we just walked through to overshadow the genuinely useful, practical safety information for anyone who actually visits the park. The real documented danger at Yellowstone isn't a hypothetical eruption, it's the hydrothermal features themselves, the boiling hot springs and geysers that draw over 4 million visitors to the park every year. Ground temperatures near these features can exceed the boiling point of water, and since 1870, at least 22 people have died from burns after leaving boardwalks or designated trails and falling into or getting too close to a hot spring. If you're ever planning a trip to Yellowstone, that's the actual safety rule worth remembering. Stay on the boardwalks and marked trails, and if there isn't a boardwalk, don't approach, no matter how tempting a closer photo might be. That's a far more useful, actionable piece of Yellowstone safety information than anything related to our hypothetical eruption scenario. And it's worth knowing regardless of how the rest of this video lands with you. I also want to put Yellowstone in context alongside other large caldera systems around the world, because I think it helps illustrate that Yellowstone isn't some uniquely doomsday-flavored anomaly. It's one of several similar systems that volcanologists study using largely the same tools and the same general framework. Places like Campi Flegrei near Naples in Italy, Taupo in New Zealand, and Toba in Indonesia are all large caldera systems with their own histories of massive eruptions in the deep past, and all of them are monitored using broadly similar approaches, tracking seismicity, ground deformation, and gas chemistry for the same kinds of escalating warning signs we walked through in our hypothetical. None of these systems, Yellowstone included, are considered by the scientists who study them to be on any kind of predictable countdown or overdue schedule, despite how often that idea gets repeated online. Volcanic systems like these operate on geological timescales, tens of thousands to millions of years between major events, and the gap since the last eruption at any of these calderas tells us essentially nothing about how close the next one might be. The same way the amount of time since your last cold doesn't tell you when your next one is coming. So here's where I want to leave this hypothetical. If Yellowstone ever did erupt, And I want to stress again that current data gives us no reason to think that's on the horizon. The most likely version of that event would be a regional, not global, disaster, probably resembling a significant lava flow rather than a repeat of an ancient supereruption. And even in the far less likely, more extreme scenario, the real science points to a serious but survivable global disruption rather than an instant civilization-ending catastrophe. Understanding the actual mechanics, the actual warning signs, and the actual probabilities is a lot more useful, and honestly a lot more interesting, than the exaggerated version of this story that tends to circulate online. If y'all found this kind of deep dive interesting, let me know in the comments, because I genuinely enjoy doing more of these science explainer style videos digging into the real mechanics behind some of these big, scary sounding natural hazard topics, separate from our usual day-to-day forecast coverage. Subscribe to this channel and hit that bell if you want to catch those when they come out. And as always, if you're dealing with any actual active weather threats in your area, keep checking back here, because that's still what this channel is built around day to day. Stay curious, stay grounded in the real data, and I will see y'all in the next one. I love y'all.